The FIA has just launched an investigation, and it involves Aston Martin's Honda engine. Not after a crash, not after a protest, but immediately after pre-season testing ended. And here's why this is explosive. A reported 4-second per lap deficit. Up to 160 horsepower disappearing halfway down the straight. A hybrid system that cannot recharge under full braking load. And now the governing body is asking questions. This was supposed to be the start of a new era. Adrian Newey's first Aston Martin masterpiece. A full works Honda partnership. Fernando Alonso chasing one last championship window. Instead, the car is overheating. Vibrating. Cut open in the garage just to survive. And according to internal reports, it may not even be meeting minimum energy recovery expectations. That is not a slow start. That is a red flag at the highest level. By the end of this video, you will understand what triggered the FIA's attention, what Newey allegedly told officials behind closed doors, and why Aston Martin could be entering Race 1 under technical scrutiny. If you care about what is really happening beneath the surface of Formula 1, subscribe now. Because this situation is bigger than anyone expected. Pre-season testing is over. 3 days in Bahrain. And instead of leaving with confidence, Aston Martin left with questions. Serious ones. But to understand why the FIA is now involved, we need to rewind. Because the problems did not suddenly appear in the desert heat. They started quietly. Barcelona. What was presented publicly as a routine filming day. Low mileage. Controlled environment. Nothing competitive. But internally, that day exposed the first cracks. The AMR26 arrived late to the circuit. Assembly complications. The rear packaging so tight that even basic engine components were difficult to access. Adrian Newey pushed the concept to the extreme. Ultra compact. Aggressively wrapped around the Honda power unit. The goal was clear. Maximum aerodynamic efficiency. Minimum drag. Clean airflow to the diffuser. On paper, it was brilliant. On track, it struggled to breathe. Within just a few consecutive laps, temperatures began to spike. And not slightly. This was February in Spain. Cool air. Low track temperatures. Yet the energy store was running hotter than predicted. Honda initially believed it was a sensor calibration issue. A minor anomaly. But the data kept repeating the same pattern. Under braking, when the hybrid system attempted to harvest energy, battery temperatures rose aggressively. The control software intervened. Protection mode activated. Recharge stopped. That detail is critical. Because under the 2026 regulations, electric power represents roughly half of the total output. If the battery does not recharge properly, the car cannot sustain full deployment down the straights. At Barcelona, the team limited mileage. They downplayed the issue. Publicly, everything was part of the learning process. Then came Bahrain. And Bahrain does not hide weaknesses. Day 1. Lawrence Stroll begins the program. Short runs. Data collection. Within dozens of laps, the power unit drops into limp mode. Energy delivery inconsistent. Deployment fading earlier than expected. Not during qualifying simulations. Not under extreme pushing. During controlled testing. Then Fernando Alonso steps into the car. And on his third lap, the system shuts down. Electrical failure. No deployment. No continuation. Garage time increases. Track time disappears. But here is where the situation escalates. Engineers start analyzing energy traces. And the pattern becomes undeniable. The car accelerates normally at corner exit. For the first section of the straight, everything looks competitive. Then halfway down, deployment cuts abruptly. Clipping. Hard clipping. The combustion engine is left alone. And that results in a massive straight-line deficit. Reports indicate up to 160 horsepower loss once the battery drains. That is not marginal. That is devastating. Fernando Alonso reportedly described it in simple terms. The car does not run. Not a balance issue. Not fine-tuning. Raw power. Missing. And now imagine how that sounds inside a technical meeting with the FIA present. Because when Adrian Newey reportedly told officials that the engine was not meeting expected recovery levels, it transformed a performance issue into a regulatory discussion. If a power unit cannot operate within declared recovery parameters under normal conditions, governing bodies will ask why. Is it thermal instability? Is it calibration misalignment? Is it a homologation discrepancy? The FIA's interest is not about Aston Martin being slow. It is about ensuring the hybrid system behaves within safety and regulatory frameworks. And there is another layer. Lawrence Stroll reported severe vibrations at lower engine speeds. Those vibrations are believed to have damaged gearbox mounts and electronic sensors. Why is that important? Because emergency engine maps were being used. With limited electric deployment, the combustion engine had to operate in non-optimal rev ranges. That creates harmonic resonance. Mechanical stress increases. Reliability risk grows. And when reliability becomes unpredictable, safety questions follow. By day 2 in Bahrain, Aston Martin had to open large cooling outlets in the bodywork. Emergency cuts. Improvised ventilation. The aerodynamic philosophy compromised in real time. More drag on the straight. Less stability in corners. The car looked slower. Because it was slower. By the final day, spare battery units were reportedly unavailable at the circuit. Running was reduced. Programs shortened. Data incomplete. And that is how preseason ended. Not with long runs and confidence, but with overheating concerns, vibration issues, energy recovery shortfalls, and now regulatory scrutiny. And this is only the first layer of the investigation. Because what Honda admitted publicly adds even more pressure. And that changes everything. What Honda admitted publicly is what truly intensified this situation. Because after testing ended, they did not deny the issue. They confirmed it. Honda acknowledged abnormal thermal behavior in the energy store under aggressive charging cycles. In simple terms, when the car tries to harvest energy under heavy braking, the battery overheats faster than expected. And when it overheats, the software intervenes. It protects the system. It limits recharge. It reduces deployment. That admission alone explains the straight line clipping. But it also raises another question. Why did simulation data not predict this? Honda admitted that their dyno simulations in Japan did not perfectly match real-world conditions in Bahrain. That is a serious statement. Because power units are homologated based on declared operating parameters. Thermal loads. Energy recovery thresholds. Deployment behavior. If track reality diverges significantly from lab projections, governing bodies want clarity. And that is where the FIA's investigation becomes crucial. They are not accusing. They are verifying. They need to determine whether the recovery shortfall is purely a reliability limitation, or whether the unit is failing to operate within its declared technical window. And here is where the tension inside the partnership becomes visible. Honda's engineers are suggesting that the AMR26's extreme packaging is part of the problem. The size 0 bodywork designed by Adrian Newey may be restricting airflow to critical hybrid cooling components. If airflow is insufficient, temperatures spike. If temperatures spike, software derates. If derating happens, recharge collapses. From Honda's perspective, the engine functions properly when cooling is adequate. From Aston Martin's perspective, the engine was expected to function within those packaging constraints. This is not just engineering. It is accountability. And accountability at this level can fracture relationships quickly. Because now there are two possible scenarios. Scenario 1. The battery design is fundamentally too sensitive to thermal stress. That means hardware redesign. New cells. New insulation. Revalidation. Time-consuming. Expensive. Risky. Scenario 2. The chassis packaging is too aggressive. Cooling channels must be widened. Bodywork redesigned. Aerodynamic philosophy compromised. Also time-consuming. Also expensive. Also risky. Either way, there is no quick fix. And that is the uncomfortable truth heading into race 1. Honda is reportedly preparing a safer battery specification. Lower peak output. Improved heat resistance. That sounds positive. But it also means sacrificing performance for stability. In other words, even if reliability improves, the power deficit may remain. And here is why that matters beyond lap time. If the FIA determines that the unit's recovery behavior under race conditions differs from homologation expectations, Aston Martin could face mandatory operating limitations. Energy deployment caps. Monitoring directives. Stricter telemetry oversight. Nothing dramatic yet. But increased scrutiny changes development freedom. Now add the political layer. Lawrence Stroll invested heavily to secure Honda as a long-term works partner. He brought Adrian Newey to design the future. This was supposed to be the reset moment. Instead, before the first race, the project is under technical investigation. Internally tense. Externally questioned. And the season has not even begun. Fernando Alonso understands how delicate this moment is. He has experienced an underperforming Honda partnership before. He knows how quickly confidence erodes when power deficits become structural. Reports from Bahrain described visible frustration. Short runs. Limited long stints. Early departures from the paddock. Because drivers feel instability immediately. When deployment fades unpredictably, braking balance shifts. Rear stability changes. Corner exit traction fluctuates. Confidence disappears. And when confidence disappears, development feedback becomes less precise. Everything slows down. That is why this FIA investigation matters so much. It is not about punishment. It is about verification. Verification of energy recovery compliance. Verification of thermal safety margins. Verification of mechanical reliability under race simulation. Pre-season testing is finished. The weaknesses are documented. Honda is in damage control. Aston Martin is evaluating possible bodywork revisions. The FIA is watching. And the first Grand Prix is approaching fast. The AMR26 was meant to signal ambition. Instead, it is entering its debut under scrutiny. And the deeper question now is not whether Aston Martin can find a few tenths. It is whether the foundation of this project is stable enough to build on at all. Because if the core issue is architectural, this is not a small delay. It is the beginning of a very long season. And this is where the situation becomes even more uncomfortable. Because an investigation, even if it ends without penalties, changes perception. Inside the paddock. Inside the factory. Inside the garage. When the FIA starts asking technical questions about your power unit before the first race, it sends a signal. It tells rival teams that something is not aligned. It tells sponsors that stability is not guaranteed. And it tells your own engineers that scrutiny has begun. Now imagine being Adrian Newey in this moment. You designed one of the most aerodynamically aggressive cars on the grid. You optimized airflow around a compact, high-efficiency power unit. You shaped cooling pathways assuming specific thermal tolerances. And suddenly, you are being asked to widen bodywork. Increase cooling volume. Compromise airflow. Before race 1. That is not evolution. That is retreat. And retreat at the beginning of a new regulation cycle is costly. Because 2026 is not just another season. It is the start of an era. The teams that understand their packages early gain compound advantages. Correlation improves. Development becomes cleaner. Confidence grows. Aston Martin, meanwhile, may enter the season troubleshooting foundational instability. That delays everything. Upgrade schedules. Performance targets. Strategic direction. Now consider the mechanical chain reaction. If cooling is insufficient, you increase airflow. Increasing airflow increases drag. More drag reduces straight-line efficiency. Reduced efficiency forces higher energy deployment demands to compensate. Higher deployment increases battery stress. Battery stress increases temperature. And the cycle begins again. This is why hybrid systems are so complex. Every change influences another subsystem. There is no isolated fix. And the FIA knows this. Which is why their investigation is not about finding a quick technical fault. It is about understanding whether the power unit's behavior under race conditions is predictable and compliant. Because unpredictability is a safety concern. If harvesting spikes temperatures beyond safe thresholds under normal braking loads, that must be examined. If vibration profiles exceed expected tolerances due to emergency engine mapping, that must be documented. And when those two elements combine, scrutiny intensifies. Meanwhile, Honda is accelerating production of revised battery units. Improved thermal insulation. More conservative deployment curves. Safer calibration maps. But every conservative adjustment carries a performance cost. So even in the best-case scenario, Aston Martin may stabilize reliability while remaining significantly down on peak power. And in modern Formula 1, a consistent half-second deficit feels heavy. A multi-second deficit is devastating. Now think about race 1. If the car qualifies near the back due to limited deployment, overtaking becomes difficult. If energy recovery fades mid-race, defending becomes impossible. If cooling requires lifting on straights, strategy becomes compromised. Suddenly, your opening objective is not fighting for points. It is finishing. Collecting data. Surviving. That is not the message Aston Martin wanted to send after investing so heavily in this partnership. And there is a psychological element here that cannot be ignored. When a project launches under pressure, every small issue feels amplified. A minor sensor glitch becomes a headline. A routine vibration becomes a rumor. Confidence erodes faster than performance can be rebuilt. But here is the defining question. Is this a temporary miscalculation that will be corrected within a handful of races? Or is this the beginning of a structural mismatch between chassis philosophy and power unit capability? If it is temporary, aggressive updates and refined thermal management could stabilize the AMR26 quickly. If it is structural, redesigning cooling architecture mid-season will cost months. And months at the beginning of a regulation era can define the entire competitive cycle. The FIA investigation will clarify compliance. Honda will attempt to restore stability. Aston Martin will evaluate whether aerodynamic compromise is necessary. But none of those actions guarantee performance recovery. Preseason testing is finished. The data has been analyzed. The concerns are public.